Hello viewers, in this presentation we are going to talk about elasticity. There exist certain solids which regain its size and shape as soon as the deforming forces are withdrawn. Similarly, in case of certain substances, even if we withdraw the deforming force, the object stays deformed. The property of a body by virtue of which it tends to regain its original shape and size when deforming forces are removed is called elasticity. All the solid materials show the property of elasticity. The greater the elasticity of the body, the greater is its tendency to regain its original shape and size even after the removal of the deforming forces. Perfectly elastic body. A body which regains its exact shape and size immediately after the removal of the deforming force is called a perfectly elastic body. Perfectly plastic body. A body which does not have any tendency at all to regain its original shape and size on the removal of the slightest deforming force is called a perfectly inelastic or plastic body. No substance in nature is perfectly elastic or perfectly plastic. Although a solid can be deformed in many ways, there are only three basic types of deformations. All others are combinations of these three types of deformation. First one corresponds to change in length. On removal of the deforming force, the object regains its length. Illustrations are shown of elasticity of extension or compression. Second one corresponds to change in volume. Here, a rubber ball is pressed from all the sides and its volume decreases. When pressure is removed, the ball regains its original volume back. Third one corresponds to change in shape. To describe the nature of the applied force and the resulting deformation, concepts of stress and strain are used. When an external force is applied to a body, it changes size or shape of the body. An internal restoring force is developed in this process. The internal restoring force acting per unit area of the deformed body is called stress. Since in equilibrium, the restoring force is equal in magnitude to the external force, the stress is measured as the external force acting on unit area of the body, that is, stress equal to force per unit area. The stress developed in a body depends on how the external forces are applied over it. On this basis, there are two types of stress, such as normal stress and tangential stress. In normal stress, the deforming force is applied normally to the surface of the body. In tangential stress, the deforming force is applied parallel to the surface of the body. At next, we have strain. The change in size or shape of the body due to the deforming force or forces is called strain. An object undergoes strain due to stress. The strain is measured by the ratio of change in dimension to the original dimension of the object. That is, strain equal to change in dimension per unit original dimension. As deforming forces can produce three types of deformations in a body, that is, change in length or volume or shape, there are three types of strain. First one is longitudinal strain. When the deforming forces change in length alone, the strain produced is called longitudinal strain. It is measured by the ratio of the change in length of the body to its original length. Second one is volumetric strain. When the deforming forces produce change in volume, the strain is called volumetric strain. It is measured by the ratio of change in volume of the object to its original volume. Third one is shearing strain. When the deforming forces produces change in shape, the strain is called shearing strain. It is measured by the angle in radian through which a line originally perpendicular to the fixed face is turned due to the application of a tangential force. Now, let's discuss stress-strain curve for an elastic material. The portion OA of the graph is a straight line showing that up to point A, strain produced is directly proportional to the stress. This point A is called limit of proportionality. If the applied force is removed at any point between O and A, the wire regains its original length. The portion AB of the graph is not a straight line. That is, in this region, strain is not proportional to the stress. The slope of the graph has also decreased. This means that strain increases more rapidly with strain. However, between O and B, if stress is removed, the object regains its original length. The point B is termed as elastic limit. Now, if stress is increased beyond point B, that is elastic limit, the object behaves like plastic. At any point between B and C, if stress is removed, the object does not quite come back to its original length. The extension not recoverable after the removal of stress beyond elastic limit is called permanent set. The point C is termed as yield point. If the stress is increased further beyond point C, the object lengthens rapidly until we reach the point D called ultimate strength or breaking strength. Beyond point D, even a stress smaller than C may continue to stretch the wire till it breaks. From this stress-strain plot, we can say within elastic limit, the strain produced in an elastic object is directly proportional to the stress. That is, stress is proportional to strain. Or in other words, stress per unit strain is a constant. This proportionality constant is termed as modulus of elasticity. Now, based on the nature of stress and strain, this modulus of elasticity can be classified as follows. First one is Young's modulus. It is defined as the ratio of tensile stress to longitudinal strain. Mathematically, it can be represented as capital Y equal to FL by A delta L. Next one is Buck modulus. It is defined as the ratio of normal stress to volumetric strain. Mathematically, it can be represented as K equal to minus of PV by delta V. Another key term related to Buck modulus is compressibility. Compressibility of a material is a measure of how easily the material is compressed. It is expressed as reciprocal to Buck modulus. Next modulus of elasticity is shear modulus. It is defined as the ratio of tangential stress to the shearing strain. Mathematically, it is represented as eta equal to FL by A delta L. Next point of discussion is related to Poisson's ratio. Whenever we stretch any object, its length increases at the same time its diameter decreases. Thus, there occurs longitudinal as well as lateral strain. Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain. Mathematically, it is represented as sigma equal to minus of delta D by D times L by delta L. We have so far defined three modulus of elasticity and Poisson's ratio. These four parameters are related to each other using these equations. Y equal to 3k times 1 minus sigma, y equal to 2 eta times 1 plus sigma, sigma equal to 3k minus 2 eta by 2 eta plus 6k, and 9 by y equal to 1 by k plus 3 by eta. On the basis of elastic properties, materials can be classified as ductile material, brittle material, and elastomers. Materials which show large plastic range beyond elastic limit are called ductile material. Those materials which show small plastic range beyond elastic limit are called brittle materials. Materials which do not obey Hooke's law within the elastic limit, that is, within elastic limit, stress strain curve is not actually a straight line, are called elastomers. At next, we obtain an expression for elastic potential energy in a stretched wire. When an object is stretched, work has to be done to deform the object. This work done is stored in the body in form of elastic strain energy. In general, work done for a small extension can be represented as delta W equal to F delta L, and we know F equal to KL. Therefore, W equal to half of FL, which is equal to U. We can also express the above expression in the following form: U equal to half of F by A times small l by L times L times A. Therefore, strain energy per unit volume becomes half of stress times strain. Some important terms related to elasticity are elastic lag, elastic fatigue, and creep. In principle, as soon as stress is removed, strain should also become zero. However, in reality, we observe a lag in gaining the original size when stress is removed. This lag is termed as elastic lag. If a material is subjected to repeated stress over a long period of time, it becomes weaker. That is, the strain produced by a given amount of stress increases. This loss of strength of the material because of repeated stresses is known as fatigue. The gradual increase in strain, which occurs when a material is subjected to stress for a long period of time, is known as creep. To summarize, in this presentation, we have discussed the concepts of elasticity and defined various terms and parameters associated with it.